Okay, we are starting lesson 4, and so it's session 1 for that. What we're going to explore for the next few sessions is multiplying multi-digit numbers. With the last lesson, we were really just focusing on single digit, so we're going to step it up a bit and use multi-digit numbers. So, one way to think about that is we have a number, for example, 124 times 25. So we have a 3-digit number multiplied by a 2-digit number. And traditionally, we set up the numbers vertically. That means up and down. So as you can see here in the first part, what we do is we multiply by that 5. We multiply that 124 by 5. 5 times 4 is 20. 5 times 2, or 5 times 2 is actually 5 times 20, gives us 100, and 5 times 1 is actually 5 times 100, which is why we get the 500. And then over here on the other side, actually I should use blue. Give me 1 second to get rid of that. We can do it this way. We can do everything by 20. So 20 times 4 is 80. 20 times 20 is 400. And 20 times 100 is 2,000. Now, the numbers you see here at the bottom, these are called partial products. That means it's part of the total product for this, the product being the answer for a multiplication problem. So just keep that in mind. Yep, the total product or product is, you just think of that as the answer for multiplying. I'm just put mult right there, answer for multiplying. So, but alone, these answers do not give us the total product. Total, as you know, that word can let us know that we're supposed to add them up. 620 plus 2,480 is 3,100. So what they're doing here is trying to show you that part of multiplying with multi-digit numbers is just multiplying in 2 different phases. All right, let's look at, so partial products are the basis of this thing called the standard algorithm for multiplying multi-digit numbers. An algorithm is a set routine or steps used to solve problems. I mean, in the case of this problem, of course, the standard algorithm is where we set it up just like this, and then we can carry our numbers, do that, and do that, and then just use blue. We'll have 2 times, don't forget to add our little 0 here. 2 times 4 is 8, 2 times 2 is 4, and 2, and then we got 0, 10, 11. So 3,100. This is your standard algorithm, or as we probably think of it, as the normal way to do the math. But partial products is something we're going to talk more about for this lesson, just to kind of get some good background information. Again, here's another example of it. I just did it on the other page, so I'm not going to spend too long on this one, but here you go. You can, and again, you can see where we carried these numbers up here and did it that way. So that's the goal. That's where we want to be as far as how to solve these problems. Another way of doing this math is doing this thing called an area model, which is basically just a visual way to see multiplying multi-digit numbers. So, for example, the standard problem for this one, city has a rectangular park that's 143 feet by 32 feet. That's the standard way that we look at a problem. But if you notice, it breaks down the 143 into 100, 40, and a 3. Basically, our ones, our tens, and our hundreds spaces. It breaks the 32 into 3 tens and 2 ones. And what you're doing here with the area model is multiplying these numbers just like you would solve for the area of a shape. In this case, this one would be 100 times 30, which equals 3,000. and so on and so forth for these other ones. We'll get into solving those in just a minute, but I just want to show you why this works out the way that it does. All right. And so the goal for lesson 4 and its different sessions is for us to be able to fluently multiply multi-digit whole numbers using the standard algorithm. Fluently, that just means to the point where we understand the patterns and know exactly what to do at certain points. Fluently just means quicker or more accurately. All right, page 55 is where we're going to start our notes for today's lesson. And you will recognize this. All right, this is very similar to our area model example we used earlier. A mall has a mall is a place where you just do a lot of shopping. A mall has a rectangular outdoor space that's 127 feet by 46 feet. So here's our 127 feet, and you'll notice this is our 40s. Actually, you know what? It's already written here for us. Here's our 127 feet, and here's our 46 feet. And you'll notice here that they break it down into 100, 20, and 7. And then over here, the 46 is broken down into 40 and 6. So there's that. So keep that in mind. It wants to know what's the area of the outdoor space in square feet. Well, this is how we do it. So we're going to have these 6 rectangles once we break it down into the area model. We've got 1, we've got a second one here, 2, 3, and this gray part is supposed to be your sidewalk, 4, 5, and 6. All right, so we've got our 6 rectangles. And each of these rectangles on an area model is going to create that thing called a partial product. That's the thing we talked about earlier. And to get the product or the total product, or AKA answer, you would find the partial product or area of each of these shapes and then add them up. You total them up. So that's just how you would do that. So turn the page and we'll refer back to that picture. Okay. All right, so the area of the outdoor space is 127 by 46. So we know that's in feet. How can you find this product? Well, there's 2 different ways to find it. The first one, some of you are already thinking, standard algorithm. And that's your 127 times 46. The other way that you can do it is a way that we're going to go over a bit more, the area model. And that's, again, just going to be that shape with different spots there. So the 6 different parts and those different partial products are added up to get that. So keep that in mind. Those are 2 different ways that we can find the answer. All right, let's look at number 2 where it says look ahead. All right, when you multiply with multi-digit numbers, you need to pay special attention to the place value. It's very true. To help, you can use patterns in the numbers of zeros and the factors of a product and the number of zeros in a product. Now, let's look at this. The number of zeros in the factors, and I'm going to underline the number of zeros in the product. Now, over here on the right, like these numbers over here, all those numbers right there are factors. Those are the numbers that you multiply together to get your products. And then all of these over here on the left, these are the products. So that's what they're talking about when they mention factors and products. So pay special attention to these, like how many zeros you're using for the factors should equal a pattern for what's in your product. So if you look at this, you got 4 times 2 is 8. There are no zeros there, no problem. 4 times 10 right here, notice there's 1 0, so your answer is going to have 1 0. 4 times 500 has 2 zeros, so your answer over here is going to have 2 zeros. 20 times 2 has 1 0, so that's going to have 1 0. 20 times 10 is 2 zeros in the factors, so 2 in the product. And this one's tricky. 20 times 500 has 1, 2, 3, and that means we're going to have 3 for our answer there. So those zeros help determine the place value, which we'll go over a little bit more in detail later on in review. But just for now, just be aware that there is a pattern available to you. So when it says describe any patterns you see, the number of zeros in the product, or in the factors, excuse me, equals number of zeros in the product. That is the pattern. Again, a lot of mathematics is just pattern, finding the pattern and then recognizing why that pattern exists. Okay, let's go on to B. All right, so this one's an interesting question. Explain why the partial product 4 times 500 has 3 zeros and not just 2. Notice it has the 2 zeros right there. Erase that. And this actually has 3 total zeros. And some of you are probably noticing the answer is because 5 times 4 equals 20. So that creates an extra 0 like that. So that's why the 4 times 5 will create that 20, giving us that extra third 0. So that's why that's an exception. Okay, and lastly, why is it important to pay attention to place value and multiplying multi-digit numbers? Here's why. You want to make sure your partial products have the right amount of zeros. That is quite often the biggest issue with multiplying multi-digit numbers is having the right amount of zeros with those partial products as you build them underneath the standard algorithm. So the right number of zeros. So again, this lesson is just reintroducing us to multi-digit multiplying with multi-digit numbers. So we'll go into much more detail later on. But again, this is just a primer for that to get us ready. Homework. IXL activity. Again, IXL is 70%. If you go to 80 or 100, you get extra credit for Classcraft. It's going to be C13. It will have a star mark next to it, or go to the recommended lessons by your teacher in IXL. But multiply by 2-digit numbers and complete the missing steps. So basically, it will use a standard algorithm, and you're going to have to just figure out which numbers are missing from it. So it's a good warm up to doing these fully, because most of the problems are completed for C13, but you have to show where they got the numbers for the missing steps. So do that to 70% and you'll be all set.